to graph this, and I've pre-done the derivatives so then you don't have to actually solve them. So we're going to basically do everything all together here. We're going to do the first derivative, the second derivative, and we're going to figure out where all the nice things are on this graph. So given, this should say f of x, sorry about that. Given that f of x equals x squared minus 1 over x squared minus 4, and the derivatives are that, complete the following. Can anybody tell me what the domain of f of x is? This is grade 12 math now.
All reals excluding -2 and +2.
Yeah, so all reals excluding 2 and -2, so I'll put it down here. So the domain is, you want to write it as set. X is an element of reals. X cannot equal plus or minus 2.
Or the other way too.
Yeah. B says the zeros of the function. How do I find the zeros? That's the x-intercepts, right? What do I do to solve that? Set y to 0 and solve. So what am I looking at? X squared minus 1. So x squared minus 1 equals 0. So what is my x-intercepts? Plus or minus 1. Okay. What is my intervals where f is above the x-axis and below the x-axis? How would I figure that out? Yes, do a sign diagram of the intercept. So we're going to do, this is going to label f, and we're going to put -1 here and +1 here. And so, again, this is all grade 12 review here, right? Here, I'll raise it up for you. So on the left, you might want to factor this just to see it better, right? F of x equals x minus 1, x plus 1 over x minus 2, x plus 2, yes? Okay, so if I pick something on the left of -1, what do I get? So on top, I get what? So I get negative here, so that's positive. And, well, if you think about this for a second, what's actually happening there? Huh? Nobody knows? What?
What's happening right there?
Yeah.
Vertical asymptote.
You have vertical asymptote. So there is another section we should possibly be looking at, right? So we should be putting 2 and -2 in there as well, because it's going to actually make a difference here. So what's on the left of -2? Now look. What do we get? Negative, 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 negative. So it's going to be positive. Between that, so negative 1.5, say, negative, 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 positive. So 3, negative, and then let's say use 0 there. Negative, positive, negative, positive. So that's positive. Between those, 1.5. That's positive, positive. So negative. And then 3. Positive. So how are you going to write this now? Yeah, so f of x is greater than 0 at -infinity to -2. Do I include -2? No, that's an asymptote. And then, mind you, we're not going to include it anyways because it's not going to equal 0, right? So it's going to be -1 to 1 and 2 to infinity, yes? And it's going to be less than 0 at what? -2 to -1, 1 to 2. Okay. Right, yep. Yes, point.
Oh, never mind.
Okay. Okay. I could have made a mistake. I should actually, no, it looks like it's positive, negative, positive, negative, positive. Yeah. Okay. So, write equations of the vertical asymptotes. I'm going to do it up here. So, what's the vertical asymptotes? X equals plus or minus 2. Again, this is all grade 12 math, right? What's my horizontal asymptote at? Do you remember that from grade 12? Y equals 1. What am I looking for? The leading coefficients, if they're the same degree. Ring a bell? Okay. So now, what intervals are they increasing, decreasing, in all local extrema? So, how do I do that? I need what to figure that out?
Second.
The first derivative. Okay. So I'm going to use the first derivative. I'm going to write it out so it's further down. F prime of x equals -6x over x squared minus 4, the whole thing squared. Okay, so I'm going to do what to figure out if it's increasing, decreasing? First off, I need to find what? The critical. So who can tell me what the criticals are? X equals 0 and plus or minus 2. Okay, then what am I going to do? Sign diagram, label it F prime. Yes? So, 0, -2, +2. So I'll give you a second to maybe fill that in, because otherwise you're just blindly copying what I'm writing. Huh? Why are we looking around? You don't know what to do? So -3 goes in there. Does everybody know the bottom's going to be positive no matter what, because you're squaring it? So like all you have to do is look at the top, right? So what is it going to be? Positive, positive, negative, negative. Okay, so what's happening at -2, where it goes from positive to positive? This means it's increasing, but how come it's not changing into, like, what's happening here? Huh? Well, we don't know anything about concavity yet until we look at the second derivative, right? It's getting.
-2 is a asymptote.
It is an asymptote, so it's kind of going like this, right? And then it comes back up. So then, at that vertical asymptote, what's the line or the curve going to look like then? Is it coming back down? No, it says plus, so it can't be coming back down. It has to be going back up, right? Yeah. Okay, so now I know we've been just doing diagrams and then saying that where it's increasing, but to get full marks on the actual AP exam, you actually have to say, since F prime is greater than 0, since F prime of x is greater than 0, function is increasing. Like, that's your justification. Like, the sign diagram is your method, it's not your justification, apparently. So it's increasing -infinity to -2 and -2 to 0. Okay? Since F prime of x is less than 0, function is decreasing 0 to 2, 2 to infinity. Yes? Do we have any critical points that happen to be extrema.
0?
At 0, what's happening at 0? It's a local max. Does everybody understand why? Since it changes from positive to negative, so then we're going to say, since f of x, sorry, f prime of x goes from positive to negative, local max at 0, comma, what? We have to go back to the original, right? So what do we get? 1/4. Okay. So we got all of C done now, right? So let's go to D. D says, determine the intervals where it's concave up, down, and inflection points. So what do we have to look for that? Second derivative. So I'm going to write the second derivative out because I can't even read it here. 6 bracket 3x squared plus 4, is that right? Over x squared minus 4 to the power 3, is that right? Okay. What the heck? Okay, so what's our critical values there? It looks like plus or minus 2. Is there anything that would give us a 0 on top?
No.
No.
Plus 4.
Because you're squaring something, multiplying by 3, and then adding 4. There's no way you could get anything to get 0 out of that, right? So f double prime, negative 2, positive 2. So there's no 0, yeah. So negative 3. It's going to be positive on top no matter what. Does everybody see that?
Oh, right.
It's a cubic on the bottom, so you got to watch. You got to watch, right? At negative 3, it would be positive, though, right? At 0, it would be negative, and at 3, say it's going to be positive again. So what does that mean? Since f double prime is greater than 0, it is what? Concave up at negative infinity to negative 2, union 2 to infinity. Sorry, that's my son texting me. F double prime x is less than 0. It is what? Concave down at negative 2 to 2. Do we have an inflection point? Possibly it would be at negative 2 and 2, but we've already established that that is asymptotes. So can you have points at asymptotes? No. So there is no inflection points. Does everybody see where it changes signs? We had the possibility of an inflection point. However, this is vertical asymptotes we've already established, so there's no inflection points. Okay, I think the last thing is to sketch it, right? Sketch the curve. So I'm going to give you a second to figure it all, put it all together and sketch it. Okay, so draw your f of x. Well, I could put a y. So I had a horizontal, what did I say? A horizontal asymptote at at 1. I have a vertical asymptote at x equals -2 and x equals +2. I had a local max at, where was it? 0, 1/4. So right there, I have a local max. So I'll put local max 0, 1/4. And then it was increasing. Where's my thing here? It was increasing here. But I don't know where. The thing is it can't be increasing here because it would cross that. So let's think about this for a second. The other thing is it has to be concave up. So the only way you can have concave up and increasing would be like this, right? Because it says on the left of -2 it was concave up. The other thing is the sign diagram said it was above the x-axis. On the left of -2. Do you remember that?
Yeah.
Okay, so then it says it was below the x-axis between -2 and -1 and 1 and 2. So because we should have it going through +1 and -1 as our x-intercepts, right? So it looks like this. Again, it's concave down. It's concave down between -2 and 2. Does everybody see this is concave down? And it also said that it was increasing between -2 and 0. Then it starts decreasing between 0 and 2. Do you see that? And then it says it's concave up between 2 and infinity, so that means it has to look like this. It says it's also increasing from, it's decreasing from 2 to infinity, so it has to be going down. It also says it's above the x-axis, so it has to be like this then for that to work. So this rings a bell from grade 12 pre-cal, right?
Where did you get that all?
Okay. So we have, what kind of function is this? X squared minus 1 to the power 3.
Oh wait, no. Cubic. No, it's more than cubic.
It's more than cubic.
Power 6.
It's to the power 6. So it's 60. You could just say it's a polynomial graph. Anyways, there's no vertical asymptotes, or like all polynomials are, the domain is all reals, right? Yes? The zeros, what would the 0 be? Yes, ±1, very good. X-intercepts are ±1. So we're going to do a little sign diagram for F, and we're going to have ±1 there. And where is it negative and positive? Well, on the left of -1, if I square it, I'll get a bigger number. I'll get positive, yeah. And 0 I'll get negative, and this I'll get positive again, it looks like. So intervals where it's positive, f of x is greater than 0 at -infinity to -1 and 1 to infinity, and f of x is less than 0 at -1 to 1. Is there vertical or horizontal asymptotes?
No.
So there's none. You know that, right? In a polynomial, there wouldn't be any vertical or horizontal asymptotes. You're going to drop this. So now we're going to have to find where it's increasing and decreasing. So I need to look at what for increasing and decreasing. The first derivative, yes? So I'm going to do C here. The first derivative is f prime equals 6x, x squared minus 1, the whole thing squared. So what would I put in my sign diagram? What's the critical ones? 0 is 1. Plus or minus 1, yes. So I'll give you a second to come up with the signs for that.
Right, 0.
This one's a very cool looking graph at the end. It is, yeah. Yeah, I knew you would be. Are you not trying the sign diagram? Oh, okay, so what's the sign diagram then? It's negative. Yeah, then it's negative. Then it's positive, then it's positive. Okay, so what does that mean?
0.
Since f prime of x is greater than 0, it is increasing 0 to 1 and 1 to infinity. Yes? Since f prime of x is less than 0, it is decreasing negative infinity to negative 1, negative 1 to 0. You can, but what's happening actually at 1? It's an intercept. It's an intercept, right? No, it was an intercept. That's all it was there, right? So you gotta watch. You could put it together, but you gotta make sure that you're if you don't include it, it's not because it's a vertical asymptote. It's not. So you could have it all 0 to infinity. Okay. So what about local extrema? Yeah. So since f prime of x changes from positive to negative, there is what at 0?
Local minimum.
There is a local minimum at 0, comma.
Things from point plus sign to negative.
So sorry, it is supposed to be negative positive. Thank you. Look at you. Negative to positive. There is a local min, that's still true, at 0, comma, negative 1.
Yeah, because negative 1 cubed would be.
Negative 1 cubed would be, yeah, negative 1. Okay, intervals where they're, sorry, that's all we have to do for C. D, concave up and down. So D, we need to look at what? F double prime is equal to 6x squared minus 1, 5x squared minus 1. Okay, so what would go on our sign diagram for F double prime?
Positive negative 1.
Positive negative 1.
Positive and negative square root of 1 over 5.
Yeah, square root, plus or minus the square root of 1 over. So the square root of 1 over 5 would be 1 over root 5, right?
Easy.
Yeah, and you don't have to rationalize anything. You could even leave it as the square root of 1. You don't have to reduce anything in this. You know what I mean?
The thing is, it would be less.
So anyways, it's going to be 1 over root 5 and negative 1 over root. I just have to simplify the 1. So there you go. Okay, so I'll give you a second to figure out the signs.
Okay. What's the value of 1 over root 5?
Well, you know 0 would be between here.
Yeah.
So the thing is just pick something that's really close to negative 1
So
then.
negative 0.9.
Yeah, negative 0.9. And then you'd be on the safe place. Yeah, yeah. Because otherwise you don't have, if this is a non-calculator part, you don't know what that would be necessarily quick. Remember, speed is important.
Exactly.
So I would just pick something that's really close on the right of negative 1, which would be negative 0.9. And so that would be negative there, but that would be positive there. So what do we get? That would be negative. And on the left of that, that's positive. And then 0 goes in there, you get positive. And then again, pick something that's very close to 1, so 0.9 again. So what are you going to get there? Negative, and then positive. Okay, so then what does this tell us? So, since isn't what? What's wrong? Okay, since f prime double prime is greater than 0 at negative infinity to negative 1 union negative 1 over root 5 to 1 over root 5 union 1 to infinity, it is concave. What? Up, yes. Since f double prime is less than 0 at negative 1 to negative 1 over root 5 union 1 over root 5 to 1, it is what? Concave down. Now we have changing of signs. So what does that indicate in a, we have an inflection point possibility. We actually have the possibility of 1, 2, 3, 4 inflection points. None of the, we don't have anything that's undefined, so they're all going to be inflection points, right?
Yep.
So we know since f double prime changes sign, inflection points at negative 1, what was the point at negative 1? That was the x-intercept, right? So, right? Negative 1, 0, 1, 0. That's 2 down really easy. So now we need to figure out if 1 over root 5 goes in there and you square it, what do you get? You get 1 over 5, and then you have to subtract 1. Does everybody see what I'm doing here? I'm taking 1 over root 5 and squaring it. I get 1/5. Subtract 1 is negative 4/5 to the power 3 would be negative.
64.
Yeah.
Oh, yeah.
And then actually the other one would be the same thing, but right? No, it would still be because you're squaring it, right? You're squaring it, right? So you're going to get the same negative 64. So if you want, you could put plus or minus there. Actually, I could have probably combined those as plus or minus, right? Okay, so now we're going to graph this. Holy smokes.
Okay, let's do it.
Yay, let's do it.
No, I shouldn't start.
Let's put all the, maybe I'll give you a head start on this because I think it is an art to be able to put this all together and get a...
Let's do it.
We have an x-intercept at negative 1 and positive 1. We have a local min at 0, negative 1. I have a inflection point also here. So IP, and then I also have an inflection point at negative, negative, positive, negative. So that is an inflection point and an inflection point at negative 1 over root 5, negative 64 over 125. Josh is on video saying, oh, that's cool. Negative 64 over 125. Okay, then it is what's happening there. It's above the x-axis. It's above the x-axis on the left of negative 1. And it says it is decreasing, sorry, I'm looking at the wrong graph. It's decreasing. Where do I have it? It's decreasing from negative infinity to negative 1. So it's coming down. And then what's the concavity there? It is concave up. So it's going like, and make sure you have a change of inflection here, right? So it's going like that. Concave up. You have to forcibly change the concavity now, even though it's still decreasing. So you have to kind of go like that, right? That's how you're going to make a concave down. You have to change the concavity. Do you see what I'm saying? Concave down there, right? Yeah. Then it's concave up again. So concave up. Then it's concave up again. And then it changes it again. Oh, actually, still concave up there, right? Well, the concave down between... It's a concave down here. This is concave up. This is concave down. And then it goes like that, concave up again. That's what I'm saying. It's kind of a cool looking graph. Looks like a deer or something. So, example 3. The domain of f of x. Is there any restrictions in the domain for f of x? Again, this is f of x. I don't know why I keep on forgetting the f there. So it's negative infinity to positive infinity. Everybody see that? There's not a vertical asymptote at the bottom, right? I mean, there's not a 0 at the bottom, so there's no vertical asymptote. The zeros, what's the 0?
0.
0. So x-intercept 0. Because it's just x. So set y to 0 and solve. Intervals where it's above 0 and below 0, so we will do a little sign diagram. This is much easier, yeah. So I put, say, negatives in. Does everybody see the bottom will be positive no matter what? Yeah? So the top will be negative and that will be positive, so that's pretty easy. So I'm gonna get sloppy now. I'm not gonna write out all my intervals. We're just gonna do the sign diagrams, okay? This is not what you're supposed to do, but just for time's sake to get going here. Okay, vertical asymptotes, horizontal asymptotes. Is there a horizontal asymptote? We already established there's no vertical asymptote. No vertical asymptote. Is there a horizontal asymptote? Yes, at y equals 0. Do you remember how you can tell? Did you also know if you do the limit as x goes to infinity, that is the horizontal asymptotes, plus or minus infinity. That's the far ends, and it tells you, if you look in there, you'll get, you remember you factor the highest power of x out, and you'll get 1 over infinity, which is 0, right? All kind of puts together now, right? Okay, intervals where it's increasing and decreasing, so I'll do an f prime graph. What do we get there? What do I put on there?
1?
Yeah.
That's when the top is 0.
But also something else, though. Plus or minus 1, right?
Yes.
Can you get a bottom 0?
No.
You cannot. Okay, so does everybody see the bottom again will be positive no matter what? So we just have to look at the top. So negative 2 squared, that'll definitely be negative. 0, that'll be a positive. 2, that'll be a negative. Everybody agree? Yep. So, do we have local extrema? Yeah, so what's happening at negative 1? It's going from decreasing to increasing. That's a local min. Negative 1, what? Plug her in. Where do we plug it? Negative 1/2. Very good. And this is a max at 1 comma 1/2. Very good. Okay, now we're going to do f double prime. Okay, f double prime. What are we looking at to put on there? Nothing from the bottom again, because it's pretty much the same as the bottom each time. What about the top? What's going to go on there? 0 for sure. What's the other one? Plus minus root 3, very good. Okay. Now we're going to go on the left of negative root 3. So pick a... You could, to be on the safe side, you know negative root 4 would be there. That would be negative 2, right? So negative 2, you get negative, positive, and this is positive. So this is going to be negative, yes? Again, negative root 1 is just negative 1. So you can plug negative 1 in there. What do you get there? Negative, negative, so positive. And then you'll get the same thing over here, right? Because it's the same thing. Oh, sorry. No. No, because it's a minus. Yeah, because 1 squared minus 3, you're going to get negative. And then 2 goes in there and you'll get positive again. So that means it's concave up. Concave up. I'm just going to verbally say it. Concave up between where it's positive there and concave down here, right? Okay. Do we have an inflection points? Yes. So we have an inflection point here. What is my inflection point? Negative root 3, comma. Negative root 3 over 4. What about 0? Is that an inflection point? Yeah, and we already calculate. No, we didn't calculate a 0. It is 0. So inflection point 0, 0. And then inflection point root 3, comma, root 3 over 4, yes? Okay. So now we're going to sketch it. If it's an asymptote. It has to change sign, and then it can't be an undefined region, right? Yeah. So, yeah. Oops.
Yeah.
So does everybody see it's totally below the x-axis on the left of 0, so make sure when you're doing that, right? The concavity is, it's switching concavity here at negative root 3, and it's decreasing on the left of. So how do we have decreasing and negative? Remember, we have to have an inflection point. And it has to be below, right? It's coming from that way. It's coming down. So, by the way, negative 1/2, if I were to do a quick calculation here, is it below negative 1/2? Well, think about this for a second. Negative 1/2 would be negative root 4 over 4, right? So that means this is above it, right? So I need to make this a little bit lower because otherwise I'm not going to be able to get this all in, right? We'll just make it work a little bit better instead of making it to scale so much. Okay? So it's coming like this. It's changing concavity at this point, negative root 3, comma, negative root 3 over 4. Then it's going back up. It's still concave up, so it's still going like this, right? And then it's changing concavity here, right? So then it's going from 0, it's concave down, so it's looking like that, right? Then it's changing. This is a local max here, right? So it's changing concavity. It's like this. This is concave zeros. Sorry. Yeah, it is. I gotta erase it actually. So concave up, then it's concave down, then it's concave up. No. Ooh. It's concave down to the root 3, then it's concave up
Until 0.
until, no, I'm already past 0. It's concave down at root 3. Oh, but root 3 is on the other side. Shoot! Right, because there is so it's going to a max, then it's going concave down and going back here. Do you see? Here's the max, then there's the concavity change right there.
Yeah, just
Which one of the points is the inflection?
Here's the inflection point here, here's the max, 1, half.
Oh, so that asymptote at y equals 0 doesn't apply to 0.
It's off. Okay, domain. Domain. Negative infinity to 0, 0 to infinity. Does everybody see there's a vertical asymptote at x equals 0? Is there a 0?
plus or minus 1 over root 3.
Plus or minus 1 over root 3. So x-intercept plus or minus 1 over root 3. Intervals where they're above and below. So that would be an f. So now we have our negative 1 over root 3, positive 1 over root 3. Yeah? And so at 0, that's positive. You could pick, a big number like 10. It's going to be negative, right? And if you pick negative 10, it'll be positive, right? Because negative root 10, you'll get negative on top, but then you have a negative there, yeah? We should be putting 0 in there. So what's close to 0.1, I guess? 0.1 would be, it looks like it's going to be positive there. And then on the left, if you negative 0.1, it'll be, but then you'll get a negative at the bottom though, right? So then it should be negative, right? Yeah, good thing that was pointed out, yes. Okay, horizontal asymptote, anybody? Y equals 0 because there's a bigger denominator on the bottom. Okay, intervals where it's, so f prime, we have to have 0 and plus or minus 1. Okay, so if I put negative 2 in there, I'll get positive, yes? Somebody check my work. If I put, say, 0.1 in there,
It'll be very small.
it'll be negative, right?
Yeah.
And then if I put it'll still be negative, and then it's positive again, yep. Okay, so then that means it's increasing, decreasing, decreasing. So we have the potential here, or we do have what going on at negative 1? A max at negative 1, so that's negative 1, comma.
Two.
And then here I have a min
One.
at 1. Yep. Very good. And then f double prime looks like 0 again. Then I have what? Root 2 and negative root 2?
Yeah.
So let's say 2 goes in there. Actually, 2 is bad because then I'll get a... No, I won't. Okay, 2...
So it's negative 12 on top, and then it's...
You get 0.
2 or negative 2?
If I put a negative 2 in there, I will get more negatives, right? Oh, but then I'll have a negative on the bottom, so then it'd be positive. And then 1 goes in, or sorry, negative 1 goes in, I'll get negative. And then 1 goes in, I'll get positive. Say 3 goes in, or you could have 2, doesn't matter. I will get negative. So I have inflection points, yes? Inflection points at negative root 2, comma. It's exhausting, hey? Huh? Negative root 2.
0 would be an inflection point, right?
Negative 5.
0 is an asymptote, so it can't be an inflection point, so I've got to be careful there. Inflection point here at root 2, comma. So root 2 squared is 2. 2 times negative 3 is negative 6 plus 1 is negative 5 over the cube root of. So that's a negative over negative, so it's a positive 5 over the cube. So I'm just going to put 2 to the power 3 over 2. That's crazy. 5 over 2 to the power 3 over 3 over 2. And then this would be root 2 goes in there.
The same thing, just negative.
It's the same thing but negative.
It's
Yes. Yes.
Whew. Okay, let's put it all together and we're done. Okay, so we have an asymptote at 0. We have x-intercept at 1 over root 3, negative 1 over root 3. We have a horizontal asymptote, far left, far right. We have a local max at negative 1, 2. So this would be over here, say right there, max. And then we have a local min. Let's go here. 1 comma negative 2, yes? And then we have it's increasing to negative 1. And it's concave. Oh, I need to put that inflection point in. So that would be, say, here. So it's concave, then it goes like this. So here's my first inflection point. Yes? That's the negative root 2. Because it's concave up. Then it's going concave down all the way to hitting the asymptote there. And it is decreasing. So it's going to go like this, right? Yeah. Huh? And then well, look, this is concave down all the way, right? Yeah. And then from 0 it's concave up. And it's decreasing, and it has to hit that, so it's going like this, right?
Yeah.
It's concave up, and then it hits, it's a mirror image, yeah, essentially. And then it changes concavity when it hits that inflection point right there, and then it's going to continue like that.